I've seen cancer firsthand. It's more than a disease. It's a fight, a roller coaster, a reality that touches nearly every life. I've lost friends, and I've celebrated with others who beat the odds. Cancer. We've all been touched by it. But what if the fight against cancer began before we were even born? On January 27, 2025, a new discovery suggests just that, and it could change everything we know about cancer risk. Let's dive into this groundbreaking finding and explore what it means for the future of cancer research, prevention, and hope. Imagine this. The risk for one of humanity's greatest challenges might be written into the earliest chapters of our story. A study from the Andel Institute has revealed that cancer risk could be influenced by processes that occur while we're still developing in the womb. Think of your DNA as a symphony, with each gene playing its part. This discovery suggests that during development, some notes might subtly shift, creating patterns that could influence cancer risk later in life. It's a remarkable finding, and one that opens new doors to understanding this disease. The study uncovered two distinct epigenetic states. Think of them as two possible paths during development. One path appears to lower the risk of cancer, while the other may increase it. In the low-risk state, cancers, if they occur, are more likely to take the form of liquid tumors, like leukemia or lymphoma. In the high-risk state, however, solid tumors such as lung or prostate cancer are more common. At the center of it all is a gene called TRIM28. Acting like a conductor, it helps control which genes are turned on or off during development, shaping these critical epigenetic patterns. For decades, cancer has been understood as a disease that develops later in life, a product of aging, DNA damage, or environmental exposures, but this research suggests that cancer risk might start forming much earlier, during sensitive windows of fetal development. Here's the exciting part. Epigenetic patterns aren't set in stone. Unlike genetic mutations, they can be influenced and even altered. Imagine a future where therapies could shift these patterns, nudging high-risk states toward lower-risk ones. It's a possibility that could reshape cancer prevention as we know it. This discovery is just the beginning. Researchers have found these epigenetic states across multiple tissue types, suggesting this mechanism could apply to many forms of cancer. Imagine a simple test at birth that could identify these markers, allowing doctors to monitor higher-risk individuals. And one day, perhaps therapies could safely nudge these patterns toward a lower-risk state before cancer ever takes hold. Future studies will explore how these states influence specific cancers, paving the way for breakthroughs in diagnostics, early interventions, and treatments that target cancer at its roots. This research reminds us that understanding cancer is a journey, one that begins long before symptoms appear. And while this discovery is still in its early stages, it offers hope, a future where we might prevent cancer before it even starts. This is a rapidly evolving field, and at Misty Q Time, we're committed to exploring the biggest questions in science and beyond. Some may call it crazy. We call it curiosity. Every breakthrough starts with someone questioning the unquestionable. What if we're wrong? What if we're right? Stay curious, stay bold, and never stop questioning, because that's how progress begins. Don't forget to like, subscribe, and join us next time on Misty Q Time.